All right, now we're on to some new material. Today we'll be simplifying rational expressions. So some examples of rational expressions are given below, and basically they are the quotient of two polynomials. Now when we say quotient, that's a fancy way of saying it's one divided by another, or looks like a fraction. So 3 divided by k minus 1 is a rational expression. It's a quotient of 3 and k minus 1. Also, x squared plus y squared over 2x minus y is the quotient of two polynomials. It is a rational expression. So today we'll be looking at simplifying these, reducing them to lowest terms. So we want to simplify these expressions by using our factoring skills, and yes, that is a Z on purpose. So what we're going to be doing is answering this question. We're going to first simplify the expression, and then we're also going to state the restriction on the variable. We'll talk about what that means at the very end. Now, the way that we simplify these is we're first going to factor the numerator and denominator, and always starting with common factoring. Alright, so we spent a lot of time working on factoring, and this is why it's the most important thing to do for this new unit. Now, in the numerator, the top part, x squared minus x, I can factor out an x, and I'd be left with x minus 1. Let me extend that. Now, in the bottom, we just have x. Now, just to kind of make clear what's happening here, if I common factor an x out of the denominator as well, I'd be left with a 1. Now, the reason why I decided to do that looks a little bit funny, but what we're looking for, if you have the same common factor in the numerator and denominator, they divide to 1, or you can think of it as they cancel out. So what we have here is x times x minus 1 divided by x. So multiplication and division can be done in any order. So x times x minus 1 divided by x, we can do x divided by x first. Those two cancel out, so we're just left with x minus 1 over 1. But just for our final answers, we do not want a denominator of 1. So just x minus 1 is our simplified expression. So what do I mean now about stating the restriction on the variable? So is there a restriction on what x can be? So a variable means that it can take on any number we want. So I can put in that x equals 10, and I can evaluate what this expression is, and it will actually be the same as this right now. You can test that out if you don't believe me. But there are certain cases where x cannot be a certain number, and here's how we can tell. We never want a denominator of 0. So if you try 3 divided by 0, it is undefined. It is not possible. You cannot divide anything by 3. So basically what we're going to be looking for is what will make the denominator equal to 0. Now we don't have a denominator in our final answer, but we do in this step right here and in the original question. The denominator is x. So if that became 0, if we said x equals 0, that would be a bad thing, because that would give us a denominator of 0. So our restriction, what we say is that x cannot equal 2, so we put a line through the equal sign, x cannot equal 0 is our restriction. So here's a better looking one that we can go over. So I want to simplify again and state the restriction on the variable. So first I'm going to factor the top and bottom, and we always look for common factoring first. Common factoring is your best friend. So I see here 6x cubed minus 36x squared plus 12x. They all have a 6x in common that I can factor out. So I'd be left with x squared minus 6x plus 2. Now, in the denominator, 6x squared plus 12x, I can also factor out a 6x out of there, and I'd be left with x plus 2. Alright, so at this point, 6x is a common factor for the numerator. It's also a common factor for the denominator. So those two will divide to 1, or they will cancel out. So I'm just left with x squared minus 6x plus 2 over x plus 2. Now I'm looking at this and I'm thinking, okay, this is a trinomial, so maybe I can factor that. So let's think about this. Are there two numbers that add to -6 and multiply to +2? The answer is no, it cannot be factored any further, but it's a good thing that we checked because sometimes we can further factor this trinomial and then maybe it could even cancel out this denominator. But in this case, this is as far as we can get. That is our simplified expression. Now, what about the restriction on the variable? Now, it's not always going to be 0, but if we look at the first or the original expression here, we can't really tell, but right here when it's factored, if 6x times x plus 2, we do not want that whole thing to be equal to 0. Now, if we were to put in x is equal to 0, it would be 6 times 0 is 0, and then 0 times anything is 0. So it is in fact a restriction again. X cannot equal 0, but that's not all. If you take a look at this set of brackets right here, x plus 2, now if you imagine that we put in that x is equal to -2 inside there, -2 plus 2, this bracket would be equal to 0. Now over here, 6 times -2, that'd be -12, but it doesn't matter because this bracket multiplies it, and if it's 0, the whole thing is 0 as well. So it ends up that we have another restriction of x cannot equal -2. So I can just put a comma here and then a -2. So we can also see it in this step right here. If we substitute in a -2 for x, the denominator is 0. So make sure that you check all of your steps, check the denominators every single time for those restrictions.